But along with that, we will also do the Mohr circle here. Earlier, we have studied the Mohr circle for stress, plane stress, whereas here we will do the Mohr circle for the plane strain, and we will study the, what you say, computation of the principal strains, maximum in plane shear strain, orientation of the principal planes, orientation of the shear planes. ठीक है जी? So all this we will do with the Mohr circle here as well. And with the start, we will do the equations. We will derive the equations for the computation of transformed normal and what you say normal and shear strains. ठीक है जी? So the equations for the computation of transformed normal and shear strains, these equations will be very much similar to the equations. These equations will be very much similar to the equations of the stress transformation which we have developed. So if you recall the stress transformation equations which we have developed, that is sigma x dash is equal to sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 cos 2 theta plus tau xy sin 2 theta. ठीक है जी? Then in this case, now epsilon x dash equation which we will derive, that will be basically the stress quantities will be replaced with the strain. Epsilon x dash is equal to epsilon x plus epsilon y over 2 plus epsilon x minus epsilon y over 2 cos 2 theta plus gamma xy sin 2 theta. ठीक है जी? So these equations which we have, so these equations, stress transformation equations which we have derived earlier, we will similar to them, we will derive the equations for the calculation of transformed normal and the shear strength. So equations will be exactly similar. Only difference will be that your sigma x will be replaced with epsilon x, your sigma y will be replaced with epsilon y, whereas your shear stress tau xy will be replaced with gamma xy over 2. There will be only one change. Tau shear stress tau xy will be replaced with gamma xy over 2. Gamma xy over 2. ठीक है जी? Now in our plane strain, before plane strain, you know that we have studied the general state of the stress. ठीक है जी? In which your element will be in 3 dimension x, y, and z, and you know that on each face of the element you have normal stress and 2 shear stresses. ठीक है जी? If I talk about the face x, on face x I have normal stress sigma x and I have shear stress tau xy, tau xz. On the y face, I will have sigma y, tau yx, and tau yz. On the z face, I will have normal stress sigma z and the general state of the strain, it will be again the same. On the x face, you will have epsilon x and you will have shear strain gamma xy and gamma xz. Whereas on the y face, you will have normal strain epsilon y and the shear strains gamma y x and gamma y z. On the z face, you will have epsilon z normal stress and the shear stress epsilon this shear strain gamma zx and gamma zy. Now we know that gamma xy and gamma yx, they are complementary to one another, so we will consider it as one value of the shear strain. ठीक है जी? So the general state of the strain at a point in a body is represented by a combination of 3 components of normal strains. In the normal strains, you will have epsilon x, epsilon y, and epsilon z. We are talking about the general state of the strain in which your element is in x, y, and z directions. ठीक है जी? And there will be 3 components of the shear strain: gamma x, y, gamma xz, gamma yz. So these three components of normal strain and three components of the shear strain, these together six components will tend to deform each face of an element of the material, and like stress, the normal and the shear strain components at the point will vary according to the orientation of the element. Just like in the stress transformation, we have derived the equations for the calculation of transformed normal and shear stresses sigma x dash, sigma y dash, and tau x dash y dash. We derived those relationships in stress transformation chapter as function of plane state of the stress plus theta. So over here we will derive the epsilon x dash, epsilon y dash, gamma x dash y dash over 2 as a function of plane state of strain. ठीक है जी, plane state of strain and orientation theta. ठीक है जी. So this we will do today. So normal and shear strain components at the point they will vary according to the orientation of the element. The strains at a point are often determined by using strain gauges, which measure normal strain in specific direction. So now one thing to be noted here, the strains that you will measure by using the strain gauges. These will measure the strain gauge strain in the direction in which it is attached. Let's say if it is attached in x direction, then it will give you epsilon x. It will not give you epsilon y or epsilon z. ठीक है जी. The strains at a point are often determined by strain gauges, which measure normal strain in specified direction. Strain is basically strain is change in length over the original length. ठीक है जी. And strain values which we get from the strain gauge, they are in micro strains, means these values will be in terms of 10 raised per minus 6 micron strains. The point to be noted here that strain gauges, they are very small size. Like for the concrete, we use strain gauge having a gauge length of 120 millimeters, whereas on steel or other material like fiber reinforced polymer, we use strain gauges having lengths 20 millimeter, 40 millimeters. So smaller lengths are used on FRPs and steel, whereas larger lengths are used for the concrete. It also depends on the what you say the size of the aggregate used in the concrete. ठीक है जी, because you are now studying in your what you say this PRC. Here you will study about the aggregates and the size. ठीक है जी. So the other important point to be noted is that the strain gauges only measure the strains in the direction in which they are attached. For both analysis and design, however, engineers must sometimes transform this data in order to obtain the strain in other directions. Means to say, you can, let's say you have measured epsilon x. Now you want to calculate epsilon y and epsilon z. So strains in epsilon, strains in y and z direction, that is epsilon y and epsilon z, you can determine, or you can say you can compute using the generalized form of the Hooke's law. ठीक है जी. So not all the strains will be measured. Few strains will be measured and few strains will be computed using the equation. So similarly, in over this what you say equation, the experiments, there are two experiments related to the strains. One is about the strain gauges, other is about the strain rosette. So we will study about the strain rosette and the strain gauge in detail in this chapter. If you have any question about the introduction, please you can ask me now. If you have any question, please feel free to ask me now. Okay. If no question, then we will continue. Now, if we talk about plane strain, just like plane stress, ठीक है जी, if we talk about the plane strain, just like plane stress, you had sigma x, sigma y, two normal stresses, and one shear stress that was tau xy. ठीक है जी. So now, if we talk about the plane strain, so corresponding to sigma x, you will have epsilon x. Corresponding to sigma y, you will have epsilon y. Corresponding to shear stress tau xy, you will have gamma x y. ठीक है जी. So in general, a plane strained element is subjected to two components of normal strain, epsilon x, epsilon y, and one component of shear strain, gamma xy. ठीक है जी. Now, the thing is, when I say plane strain, you understand by the plane strain we are talking about x and y axis. ठीक है जी, or x and y plane. We are not considering x and z plane. This one. We are not considering y and z plane. We are just talking about x and y. We will just consider the sigma x normal stress about the x-axis, normal stress about the y-axis, sigma y. We are not considering any. We are not considering about considering the stress about the z-axis. We are not considering the stress about the z-axis. Fine. So we are just considering x and y plane. So this is plane state of the strain. In that you will have epsilon x, epsilon y, and you will have shear strain gamma xy. ठीक है जी. Now, plane strain element is subjected to two components of the normal strain, epsilon x, epsilon y, and one component of shear strain. One component of shear strain, gamma x, y. Although plane strain and plane stress each have three components lying in the same plane, realize that plane stress does not necessarily cause plane strain or vice versa. This is no very important thing. Now, as a general thing, you guys have studied that when you will test the steel bar in tension, there will be elongation in the steel bar along the length of the steel bar, and there will be reduction in the dia. Means to say, in the lateral direction, there is compression. The dia is reduced. So due to Poisson's effect, you can actually calculate the lateral strains in the steel bar as well. You know that the lateral strains will be in the negative, or you can say in the opposite direction to the longitudinal strains. ठीक है जी. Now the thing is, if you will have sigma x, ठीक है जी. Now sigma x, I'm talking about plane stress now. So in plane stress, we know we have sigma x and sigma y. So now when you will have sigma x, it will produce the strain epsilon x dx, ठीक है जी. And sorry, it will produce the strain epsilon x, and due to this normal stress sigma x, the change in length will be epsilon x dx, because strain is epsilon x. So change in length, let's say, is delta over the original length. Original length is dx. ठीक है जी. So this normal stress will produce normal strain in x direction. Understandable? Now the thing is, due to the Poisson's ratio, this normal stress sigma x, it will produce the strain epsilon x, and due to the Poisson's ratio, there will be a strain produced in y direction, which is epsilon y, and there will be a strain in z direction, which is epsilon z. Other way around, if you have the second stress is sigma y. So sigma y, it will produce a strain epsilon y dy. ठीक है जी, increase in the length along the y-axis. ठीक है जी. So strain sigma y will produce the strain epsilon y, and due to the Poisson's effect, it will produce the strain in x-axis, and it will also produce the strain in z-axis. Now the problem comes here, that we have said that in plane stress there are only two normal stresses. So it means correspondingly in plane strain, there can be only two normal strains. There can be epsilon x and epsilon y. There cannot be epsilon z. ठीक है जी. Now to have this concept, to have this plane state of the strain, so to have this plane state of the strain, what we do, we consider the Poisson's effect as zero. ठीक है जी. So if we just consider Poisson's effect zero, so it means sigma x, it will produce the normal strain epsilon x, and epsilon x will produce this change in length epsilon x dx. This is sigma y, it will produce normal strain epsilon y, and this is the change in the length along the y direction. ठीक है जी. It will not produce, sigma y will not produce what you say, epsilon y will not produce a component in z and x direction. So similarly, epsilon x will not produce a component of the strain in y and z direction. Okay, so Poisson's effect is zero, then you can have a plane state of the strain. So the plane strain and plane stress each have three components lying in the same plane, means you have sigma x, sigma y, tau xy. So correspondingly, you should have epsilon x, epsilon y, and gamma xy. So although the plane strain and plane stress each have three components lying in the same plane, realize that plane stress does not necessarily cause plane strain or vice versa. ठीक है जी. So the reason for this has to do with the Poisson's effect. The element in figure, this which we have already explained, is subjected to plane stress, sigma x and sigma y. Not only are normal strains epsilon x and epsilon y are produced, but there is also an associated normal strain epsilon z, due to Poisson's effect. This is obviously not a case of plane strain. This is obviously not a case of the plane strain. In general, then we have to assume that the Poisson's ratio mu is zero. The Poisson effect will prevent the simultaneous occurrence of plane strain and plane stress. If you have any question about this, please ask me now. If you have any question, please ask me now. If it is clear, we are proceeding further. So to have plane strain means if you want to have a plane strain state, in that you have only epsilon x, epsilon y, and gamma xy. To have this, you need to have Poisson's effect zero. Okay, mu will be taken as zero. If there will be Poisson effect, then there will be epsilon z. And in the plane stress and plane strain, there are only you will have the stress in x and y direction. So correspondingly, you will only have the strain in x and y direction. You cannot have the strain in z direction. If this is clear, then let's proceed further. General equations for the plane strain. So now we are proceeding towards the derivation of the plane strain. So general equations of the plane strain transformation. So it is important in plane strain analysis. Sorry, let me come here now. So before establishing the sign strain transformation equations, so before establishing the strain transformation equations, we have to establish the sign convention. So normal strains epsilon x and epsilon y, they will be considered positive if they cause elongation along the x and y axis. respectively. So means to say sigma x gap निकले. So normal strains epsilon x, and epsilon y are positive. Means to say, if you have tensile stresses are those stresses which are producing elongation in the element. So corresponding to sigma x, epsilon x is produced. Corresponding to sigma y, epsilon y is produced. So normal strains epsilon x and epsilon y are considered positive if they cause elongation along the x and y axis respectively. ठीक है जी. Shear strain. Shear strain is interesting now. If you focus on this element, this yellowish color is the element, actual condition or actual state of the element AOB, with dimension along the x-axis dx, dimension along the y-axis dy. ठीक है जी. Now what will happen? Sigma x will produce the strain epsilon x. So change in length will be epsilon x times the dx. ठीक है. Then sigma y, it will produce epsilon y. So epsilon y will result into the change in length along the y-axis as epsilon y times dy. ठीक है जी. Now this angle, next is about the shear strain. Shear strain. So shear strain, in actual this angle is AOB is 90 degrees. After the application of the after the application of the stresses, now this angle will change. If this angle reduces, okay, you can see there is elongation. The two ends, this end and this end, you can see they are stretched, which means this is tensile stresses are acting. So if this angle AOB, this inner angle, if this inner angle reduces, means this angle becomes smaller than 90 degrees. If this interior angle AOB becomes smaller than 90 degrees, it means your shear strain is positive. And on the other hand, if your this angle AOB becomes greater than 90 degrees, the shear strain is negative. So normal strains epsilon x and epsilon y are positive if they cause elongation along the x and y axis respectively. And the shear strain gamma xy, shear strain is represented with gamma. So shear strain gamma xy is positive if the interior angle AOB, becomes smaller than 90 degrees. So shear strain gamma xy is positive if the interior angle AOB becomes smaller than 90 degrees. This sign convention also follows the corresponding one used for the plane stress. So positive sigma x, positive sigma y. So positive tensile stresses, sigma x, sigma y, positive shear stress will cause the element to deform in the positive directions. So corresponding to sigma x, you will have epsilon x. Corresponding to sigma y, you will have epsilon y. Corresponding to tau xy, you will have gamma xy respectively. Is this point clear? If you have any question, ask me now. You can see this slide or not?
Yes, sir.
Okay. So positive stress sigma x, sigma y, tau xy. They will produce, sigma x will produce epsilon x, sigma y will produce epsilon y, tau xy will produce gamma xy. So we are assuming Poisson's ratio as 0. We are taking the Poisson's ratio as 0. So to determine at a point the normal and the shear strains. These we will just start the derivation in a very short while. To determine at a point the normal and the shear strains epsilon x dash, epsilon y dash, gamma x dash, y dash, measured relative to the x dash and y dash axis. So if we know epsilon x, epsilon y, gamma x, y, so this is plane state of the strain. So if we know plane state of the strain, we can determine the normal and the shear strains measured relative to the x and y dash axis. So only is the variable will be your angle, the angle between the x and y axis. So you can see this is your regular x and y axis. So now your x dash axis is oriented. Your x dash axis is oriented at an angle theta. ठीक है जी, your x dash axis is oriented at an angle theta, and you can see y dash axis is oriented at an angle theta. So this, if you curl your fingers, if you recall, we have determined the sign convention that if you curl your fingers from x to x dash axis. So if you curl your fingers from x to x dash axis, your thumb will point out of the plane. If your thumb is pointing out of the plane, it means the angle is positive and it is counterclockwise. ठीक है जी, curling your fingers from x to x dash axis, if your thumb points out of the plane, then it will be considered as positive. ठीक है जी, counterclockwise. And if you have x dash axis downwards, ठीक है जी, and you curl your finger from x to x dash axis, from x to x dash axis, your thumb will point into the plane. And if your thumb will point into the plane, it means the theta is negative. So counterclockwise theta is taken as positive and clockwise theta is taken as negative, same as earlier. ठीक है जी? So the sign convention is exactly the same what we have already considered earlier. Any questions about the sign convention? Any question?
सर गैमा एक्स वाई बाई 2 को दोबारा एक्सप्लेन कर दो।
किसको?
गैमा एक्स वाई बाई 2
उसका साइन कन्वेंशन पूछ रहे। So this is actual shape of the element is this one, AOB. ठीक है जी? This angle is 90 degrees. After the application of the normal and the shear stresses, if this is the deformed shape of the element. ठीक है? You can see this along the y-axis there is positive deformation because your length of the element along the y-axis has increased. And how much it has increased? Epsilon y d1. Along the x-axis, the length of your element has increased. How much it has increased? This is epsilon x dx. ठीक है जी? Then you want to know the shear strain, whether it is positive or negative. Positive shear strain is that if your angle, this AOB, if this angle AOB of the deformed shape of the element, if the angle AOB of the deformed shape is lesser than 90 degrees, if the angle AOB of the deformed shape of the element is lesser than 90 degrees, ठीक है जी, then shear strain is positive because you can see of this shear strain there is elongation along the ends. So these ends are elongated. So the shear strain is positive. So this angle AOB is lesser than 90 degrees.
Okay sir, thank you.
Now let's start the derivation. ठीक है जी? Please take out your pages and the pencil. I give you 1-2 minutes to get ready for the derivation, and then we will start it. Are you ready for the derivation now?
Yes, sir.
Okay. So, just like earlier in our stress transformation chapter, we have derived the equations for the stress transformation, that is sigma x dash. Okay, we have derived the equations for sigma x dash, sigma y dash, and tau x dash y dash. So here we will start with the strain transformation equation derivation for epsilon x dash. Okay, I am starting the derivation for the strain transformation equation epsilon x dash. After this, I will derive the equation for gamma x dash y dash, and then I will derive the equation for epsilon y dash. So first we are starting with epsilon x dash. Okay, ji? So you can give the heading derivation of the strain transformation equation epsilon x dash. Strain transformation equation epsilon x dash. Okay, ji? So to develop strain transformation equation for epsilon x dash, it is important to determine the elongation of the line segment dx dash. So let me first explain to you this figure. This is the element. This solid blue line is the element, actual dimensions of the element. This is dx. Okay, this is dy. This is along x-axis, this is along y-axis. ठीक है जी? So length of your element along x-axis is dx, length of your element along y-axis is dy. ठीक है जी? Now you have rotated the element at an angle theta counterclockwise, so it is positive. So this is your transformed x dash axis and this is your transformed y dash axis. Okay. Earlier you have measured the strains along x and y axis. ठीक है जी? आपने जो strains measure किए हुए due to sigma x and due to sigma y. Due to sigma x, you have epsilon x, so you have the value of epsilon x. Due to sigma y, you have epsilon y, so you have the strain about y-axis. ठीक है जी? There is Poisson's ratio is 0, so no effect of epsilon y on this strain and no effect of epsilon x on this strain. ठीक है जी? So these two strains are 0. ठीक है? Due to Poisson's effect, there is no additional strain. So there is only epsilon x, epsilon y. Now you want to calculate the strain, ठीक है जी, of an element which is oriented at an angle theta, x dash axis. ठीक है जी? As we have said earlier, that strain will vary with the orientation. So we want to derive the expression so that I can calculate epsilon x dash and epsilon y dash, ठीक है जी, as a function of epsilon x, epsilon y, and theta. So this is your dx dash. ठीक है जी, this is your dx dash, the length of the element along the x dash axis. So to develop the strain transformation equation for epsilon x dash, it is important to determine the elongation of the line segment dx dash along the x dash axis, and it is subjected to the strain components epsilon x, epsilon y, gamma xy. ठीक है जी? Now this line dx dash, ठीक है जी, the components of the line dx dash along the x and along the y-axis can be determined. Why we want to determine the components of the components of dx dash along x and y-axis? Because we have the strain components along x and y-axis. आपका epsilon x is about x-axis, your epsilon y is about y-axis. Gamma xy is the shear strain. We want to calculate the strain epsilon x dash. So we need to find the components of dx dash about x-axis and y-axis. So dx dash its component about x-axis will be क्या होगा जी? So dx क्या होगा? This is just simple trigonometry. You should be able to do it. बताएं. So dx is equal to dx dash cos theta and dy, the perpendicular component will be dx dash sin theta. Is it so? Dx is equal to dx dash cos theta and dy is equal to dx dash sin theta. ये दोनों तो components आपको आ जाएंगे ना simple trigonometry से. Can you find this or not? If not, let me know. अगर आपका ये आ रहा है तो good. If you are not getting it, let me know. Dx dash has two components, one along x dash axis, one along y dash axis. Along the x dash axis, it is dx is equal to dx dash cos theta. Along the y axis, it is dy is equal to dx dash sin theta. Is it fine? Is this fine? Yes, or sir. Not fine? अगर नहीं समझ आ रही या आ रही है, either way. Okay. Next is now when the positive normal strain epsilon x occurs. ठीक है जी. Now epsilon x is along the x-axis. ठीक है जी, along the x-axis. Epsilon x. Now this is the actual length of the element along the x-axis dx. Now due to the strain epsilon x, ठीक है जी, strain is epsilon x, original length is dx. So change in length will be epsilon x times dx. This is the change in length due to the normal strain epsilon x. ठीक है, because there is no Poisson's effect. So due to epsilon x, there will be no strain in y direction. So along x-axis, there will only be strain due to epsilon x. So when the positive normal strain epsilon x occurs, ठीक है जी. Now due to this normal strain epsilon x, the elongation in the dx along the x-axis is epsilon x dx. Strain आपका क्या है? Strain is epsilon x is equal to change in length over the original length. Original length is dx, strain is epsilon x. So change in length will be epsilon x times dx. This point clear?
Yes, sir.
Yes, sir.
Okay. Now you have this epsilon x dx. ठीक है जी. We want to find this component of this elongation along x dash axis and y dash axis. We want to find the component of epsilon x dx, this one, along x dash axis and y dash axis. ठीक है जी. This angle is theta. This is 90 degrees. So this is base. This is perpendicular. This is tangent. So can you can you determine these two components?
Yes, sir.
Correct. So this is due to the strain epsilon x. Change in length along x-axis is epsilon x times dx. So this is the change in length. Now this epsilon x dx we need to find it component along x dash axis and y dash axis. This is theta. ठीक है जी. And this one is epsilon x dx cos theta. This vertical component will be epsilon x dx sin theta. ठीक है. These two components are clear.
Yes, sir.
Yes, sir.
Okay. Now come to this point then. Let me know. इसको मैं जरा थोड़ा सा बड़ा कर देता हूँ. Now, sorry. Now, when the positive normal strain epsilon y occurs, ठीक है जी. Now, positive normal strain epsilon y occurs along the y-axis, so your line dy is elongated by this much. So, elongation is strain times the original length. Strain is epsilon y, original length is dy, so change in length is this one, epsilon y dy. Now, similarly, I want to find the component of epsilon y dy, the change in length along the y-axis due to the application of the normal strain, epsilon y. I want to find the component of the elongation epsilon y dy along y dash axis and x dash axis. ठीक है जी. Now this is your theta. So this will be base, this will be perpendicular, and this will be tangent. ठीक है जी. So can we find this component and this component? Base will be epsilon y dy cos theta. Perpendicular will be epsilon y dy sin theta. ठीक है जी. And this is your tangent epsilon y dy. Epsilon y dy. So please draw this figure. And find these components, epsilon y dy cos theta, epsilon y dy sin theta. If you are done with this, let me know. Done with this? Is this point clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So first was due to the positive normal strain epsilon x. Second is due to normal strain epsilon y. Okay. Now the third is your shear strain. Now the shear strain is, as we have said earlier, that the positive shear strain will result in the reduction in the angle AOB. So if you see this, this is dy, this is dx. Originally this angle is 90 degrees. Now, assuming that dx remains fixed in the position. Now I am fixing the position of dx, means this position of the element along the dx is fixed. dy is not fixed. You can only fix one dimension. They have fixed dx. dy is not fixed. So due to the application of the shear strain, what will happen? Your dy, it will move to this new dimension, new, you can say, position. So due to the application of the shear strain gamma xy, ठीक है जी, the shear strain gamma xy, which is the change in the angle between dx and dy, ठीक है जी. Originally it is 90. Now this is your position of dy. Okay. Now the change in the angle between dx and dy causes this top to move to this top. ठीक है जी. ये जो आपको horizontal line they are showing it, that is basically the shear strain. The change in the length due to shear strain as the top of dy has moved from this position to this position. So gamma xy ठीक है जी. So new position is from here to here. So this change in length due to shear strain gamma xy will be gamma xy times dy. ठीक है. Strain is gamma xy, original length is dy, so change in length will be gamma xy times dy. ठीक है जी. Now I want to find the component of gamma xy dy along the y dash axis and x dash axis. This is my angle theta. This is your base. This is perpendicular. This is tangent. So can you now find this components of gamma xy dy along x dash axis and y dash axis? Along the x dash axis, it will be gamma xy dy cos theta. Along the y-axis, it will be gamma xy dy sin theta. Can you do this, please?
Sir, can you please explain this change of position again?
Original position is this one. Okay. This is dx, this is dy. ठीक है जी. Original angle is 90 degrees. Now we are assuming that dx position is fixed. We have fixed the position of dx. dy position can be changed. Now on the application of the shear strain, your dy, its position has changed from here to here. ठीक है जी. The top of this line, dx remains fixed in the position. The shear strain gamma xy, which is the change in the angle between dx and dy, causes the top of the line dy, to be displaced gamma xy dy to the right. So dy has moved to this position. So the top moving from here has come to this point. The top of dy has come to this one. And this change in the length is आपका strain होता है. Strain is equal to change in length over original length. So strain is gamma xy. Gamma xy, original length is dy. So change in length will be gamma xy dy. And then I have computed the components of gamma xy dy along y dash axis and along x dash axis. ठीक है जी. This angle is theta. Fine. This component is the theta. This is your base. This is your perpendicular, and this is your tangent. Clear?
Yes, sir. Thank you.
Now we are deriving the equation for epsilon x dash. So we need to now accumulate, ठीक है जी, or combine the elongations due to epsilon x, due to epsilon y, due to gamma xy along the x dash axis. Now, when the positive normal strain epsilon x occurs, the line dx, ठीक है जी, is elongated by epsilon x dx, and which causes the line dx dash, which causes the line dx dash to elongate by epsilon x dx cos theta. ठीक है जी. So here we are taking now epsilon x dx cos theta, and it is pointing towards the positive x-axis, so it is positive. Then when the positive normal strain epsilon y occurs, the line dy is elongated by epsilon y dy, which causes the line dx dash, this one, epsilon y dy sin theta, to elongate by epsilon y dy sin theta. Now it is again pointing towards positive x-axis, so this is positive epsilon y dy sin theta. Then the last one is the shear strain gamma xy causes the top of the line dy to be displaced by gamma xy dy to the right, and this causes this one, gamma xy dy cos theta, to cause the elongation along x dash axis. So now I come to this one. If all of these three elongations are added together, the resultant elongation of dx dash, if all three of these elongations are added together, the resultant elongation of dx dash is एप्सिलॉन एक्स डैश आपका क्या है? चेंज इन लेंथ, ठीक है जी, चेंज इन लेंथ. So strain is change in length over the original length. So change in length delta x dash will be equal to epsilon x dx cos theta plus epsilon y dy sin theta plus gamma xy dy cos theta. Everyone is fine up till this point. यहाँ तक everyone is fine. Okay, understand?
Yes, sir.
Good. Now, earlier we have said that strain is strain. The normal strain along the line dx dash is epsilon x dash is equal to delta x dash over dx dash. Delta x dash is this one, which is your change in length along the x dash axis, and dx dash is your original length. ठीक है जी. Delta x dash is your change in length along x dash axis. Dx dash is the original length. ठीक है जी. This is the simple what you say equation of the strain. Now we have to get this. Now I will show you how we can get this working. So this is your change in strain or elongation along the x dash axis. ये आपको नजर आ रही है ना, न्यू वन एप्सिलॉन एक्स है, हैंड रिटन वन. Epsilon x dx cos theta, epsilon y dy sin theta plus gamma xy dy cos theta. So this is your elongation about x dash axis. Strain about x dash axis is equal to delta x dash over dx dash. And we have studied that dx is equal to dx dash cos theta. आपने ये यहाँ पे पढ़ा है. dx is equal to dx dash cos theta, dy is equal to dx dash sin theta. ठीक है जी. Now we are simplifying this. Okay, so dx dash is equal to dx over cos theta. ठीक है जी. Now we will equate this equation 1, that is delta x dash value in this equation. ठीक है जी. In equation 2, put the value of delta x dash in equation 2. So equating this 1 into, we will get epsilon x dash. ठीक है जी. आप ये equation, you are putting the value of delta x dash in this equation. So this equation now becomes epsilon x dash is equal to epsilon x dx cos theta. Dx cos theta. In place of dx, I have put dx dash cos theta. Dx dash cos theta into cos theta. Plus epsilon y dy sin theta. So at the place of dy, I am putting dx dash sin theta. So epsilon y dx dash sin theta into sin theta. Plus gamma xy, in place of dy I am putting dx dash sin theta. ठीक है जी. Into cos theta. Fine. Into cos theta. And then whole of this I have to divide it by dx dash. Whole of this I have to divide by dx dash. Clear? Agree with this up till this point?
Yes, sir.
Okay, now we are going to simplify this equation. Epsilon x dash is equal to epsilon x dx dash cos square theta divided by dx dash. ठीक है जी. Plus epsilon y dx dash sin square theta divided by dx dash. Plus gamma xy dx dash sin theta cos theta over dx dash. So further simplification, epsilon x dash is equal to dx dash will cancel out. So epsilon x dash is equal to epsilon x cos square theta plus epsilon y sin square theta plus gamma xy dx dash cancel out, sin theta cos theta. Everyone agree up till this point? Equation 4.
Yes, sir.
Okay. Now you have this equation, epsilon x dash is equal to epsilon x cos square theta plus epsilon y sine square theta plus gamma xy sine theta cos theta. Now I have to put the identities in this equation. Epsilon x dash is equal to epsilon x. Cos square theta can be replaced with identity 1 plus cos 2 theta over 2 plus epsilon y sine square theta. Sine square theta can be replaced with an identity 1 minus cos 2 theta over 2 plus gamma xy. Now you know that 2 sine theta cos theta is equal to sine 2 theta. Over here we have sine theta cos theta. So this sine theta cos theta will be replaced with identity sine 2 theta over 2. This is important part because in the equation you will see that tau xy is replaced with gamma xy over 2 in this equation. So gamma xy into sine 2 theta over 2. Further simplification, epsilon x dash is equal to epsilon x over 2 plus epsilon x cos 2 theta over 2 plus epsilon y over 2 minus epsilon y cos 2 theta over 2 plus gamma xy over 2 sine 2 theta. ठीक है जी, and then rearranging the elements we get the final equation as epsilon x dash is equal to epsilon x dash is equal to epsilon x plus epsilon y over 2 plus epsilon x minus epsilon y over 2 cos 2 theta plus gamma xy over 2 sine 2 theta. Agree up to this point? So this is your final equation for epsilon x dash basically.
Yes, sir.
Done? One second, sorry, where we are heading. So this is the final expression for epsilon x dash. You can see it is very much similar. Only stresses are replaced with the strains. Rest expression is same. So earlier sigma x dash was equal to sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 cos 2 theta plus tau xy sine 2 theta. Now we have epsilon x dash is equal to epsilon x plus epsilon y over 2 plus epsilon x minus epsilon y over 2 cos 2 theta plus gamma xy over 2 sine 2 theta. ठीक है जी, this is your final expression. Agree with this?
Yes, sir.
Chalo. Now, now next step is we want to derive the equation for gamma x dash y dash. Guys, we have 24 minutes, so we need to finish this. So I will proceed bit quicker. So the strain transformation equation for gamma x dash y dash can be developed by considering the amount of rotation each of the line dx dash and dy dash undergo when subjected to the strain components. Now this is your x dash axis, this is your y dash axis. Along the x dash axis you have dx dash, along the y dash axis you have dy dash. ठीक है जी. So the strain transformation for gamma x dash y dash can be developed by considering the amount of rotation each of the line dx dash and dy dash undergo when subject to the strain components epsilon x, epsilon y, and gamma xy. So you can see on the application of epsilon x, epsilon y, gamma xy, your dx dash has gone to has rotated by angle alpha, and the new position of dx dash is this one. And on the application of this strain components, your dy dash has rotated by an angle beta, and this is your new what you say location of dy dash. Now first let's consider this dx dash. Okay. First, let's consider the rotation of dx dash, which is defined by counterclockwise angle alpha. ठीक है जी? So this rotation of dx dash to new location of dx dash is defined by this angle alpha. अल्फा क्या होगा, tan अल्फा इज इक्वल टू डेल्टा वाई डैश ओवर डी एक्स डैश, ऐसे ही है जी। tan अल्फा इज इक्वल टू डेल्टा वाई डैश ओवर डी एक्स डैश, ठीक है। दिस इज परपेंडिकुलर, दिस इज बेस, दिस इज थीटा, एंगल इज अल्फा, ठीक है। फॉर स्मॉल एंगल्स tan अल्फा विल बी इक्वल टू अल्फा, ठीक है जी। सो नाउ इट कैन बी डिटरमिन्ड बाय द डिस्प्लेसमेंट कॉज्ड बाय delta y dash. This displacement we can determine delta y dash using alpha is equal to delta y dash over dx dash. Dx dash is the original length, ठीक है, along the x dash axis you have that one. Now delta y dash we can find just like delta x dash which we have found earlier. Just like this delta x dash, you find these three components. Now for delta y dash, we have already these three components. We just need to see these figures now. So in this figure, let me enlarge it because you need to see the dimensions. Okay, due to epsilon x, you along the dx direction, you have the elongation epsilon x dx. Along the y dash axis, your elongation was epsilon x dx sine theta. Agree with this? Along the y dash axis, you have epsilon x dx sine theta component. ठीक है जी? And now this is pointing downwards. Now this is pointing downwards, so this is negative because it is pointing towards negative y-axis. ठीक है जी? So epsilon x dx sin theta with negative sign. Agree with this point?
Yes, sir.
Okay. Then normal strain epsilon y acting along the dy produces the elongation epsilon y dy, and the component about the y dash axis is this one, epsilon y dy cos theta, epsilon y dy cos theta, this one vertical, and it is pointing towards upwards, it is pointing upwards, ठीक है जी? So this will be positive now, epsilon y dy cos theta. Agree with this?
Yes, sir.
Now next, with the shear strain, you have gamma xy dy, this change in length. Now this will have a component, this one, gamma xy dy. This was sine theta and it is acting downwards, so again negative, gamma xy dy sine theta. Agree?
Yes, sir.
Okay, good. Now to obtain delta y dash, consider the following three displacements components acting in the y dash direction. So you have minus epsilon x dx sine theta plus epsilon y dy cos theta minus gamma xy dy sine theta. So delta y dash, so I got delta y dash is equal to minus epsilon x dx sine theta plus epsilon y dy cos theta minus gamma xy dy sine theta minus gamma xy dy sine theta. ठीक है जी? Agree with this? Cannot agree? Okay. Dividing each term means your alpha is equal to delta y dash over dx dash. So in this equation, we will put this and divide each term by dx dash, and then using the expressions dx dash is dx is equal to dx dash cos theta, dy is equal to dx dash sin theta. ठीक है जी? And we will get this equation alpha. करें और मुझे बताएं. Let me show you. So alpha is equal to delta y dash over dx dash. ठीक है, alpha is equal to delta y dash over dx dash. Delta y dash is equal to minus epsilon x dx sin theta plus epsilon y dy cos theta minus gamma xy dy sin theta. Now we will put the equate this two in one. So alpha will become minus epsilon x dx sin theta divided by dx dash plus epsilon y dy cos theta divided by dx dash minus gamma xy dy sin theta divided by dx dash. Dx is dx dash cos theta, dy is equal to dx dash sin theta. Agree with this? No. No. We are further simplifying. In place of dx dy, we are going to put this dx dash cos theta, dx dash is equal to sin theta. So equating for these values in equation number 3. So further simplification, alpha is equal to minus epsilon x dx dash cos theta sin theta over dx dash plus epsilon y dy is dx dash sin theta. So dx dash sin theta into cos theta over dx dash. Then you have minus gamma xy, just थोड़ा सा नीचे, minus gamma xy. In place of dy you will put dx dash sin theta into sin theta over dx dash. ठीक है जी. So alpha is equal to, now we are simplifying, minus epsilon x dx dash will cancel out, so minus epsilon x cos theta sin theta plus epsilon y sin theta cos theta minus gamma xy sin square theta. So dx dash will cancel out. So on the simplification, we will take these two values common, minus epsilon x plus epsilon y into cos theta sin theta minus gamma xy sin square theta. ठीक है जी. So this is equation 5 which we had to get. Everyone got this equation 5? Everyone got this?
Yes, sir.
ठीक है जी. ये हमने सिंप्लीफाई करके अल्फा ले लिया. Why we took alpha? First we considered the rotation of dx dash, which is caused by angle alpha. ठीक है जी. And it can be determined by delta y dash over dx dash. Delta y dash is this one divided by dx dash, and after simplification you got alpha as this angle minus epsilon x plus alpha minus epsilon x plus epsilon y times sin theta cos theta minus gamma xy sin square theta. Now after this, next is beta. ठीक है जी. Beta is the line dy dash rotates by an amount beta. ठीक है जी. The angle beta can be determined by simply substituting theta with theta plus 90. The beta, because the distance between the difference between beta and alpha will be just of 90 degrees. ठीक है जी. So the angle beta can be determined by simply substituting theta plus 90 for theta in the above equation. ठीक है जी. ये above equation आपकी ये वाली. So in this equation for the beta, the same equation, but here minus epsilon x plus epsilon y sin theta plus 90 cos theta plus 90 minus gamma xy sin square theta plus 90. ठीक है जी. So you can get these, the angle beta can be determined by simply substituting theta plus 90 for theta in the above equation. So then we will use these identities. You should know that sin theta plus 90 is cos theta, whereas cos theta plus 90 is minus sin theta. Just these two identities we need to know. So beta is equal to minus epsilon x plus epsilon y sin theta plus 90 cos theta plus 90 minus gamma x dash y dash sin square theta plus 90. Now we know that sine theta plus 90 is cos theta, but cos theta plus 90 is minus sine theta. So this sine theta and this is the minus sign which is coming up, minus sine theta. Minus gamma x dash y dash, sine theta plus 90 is cos theta, so cos square theta. Okay, this is clear.
Yes, sir.
Okay, since alpha and beta represents the rotation of the sides dx dash and dy dash of a differential element whose sides were originally oriented along x dash axis and y dash axis. Okay, now is subjected to shear strain. So shear strain will be gamma x dash y dash, which is actually alpha minus beta, the change in the rotation. ठीक है जी, because actual angle was 90, ठीक है, but now even after rotation theta plus ये theta, so this was theta plus 90, but now because these two rotations alpha and beta they are not same, ठीक है जी, so the difference of these two rotations will give you the shear strain. So alpha minus beta, ठीक है जी, will give you this equation. And after simplification, we will get this. So let's do this now in further. So beta is equal to minus epsilon x. Beta and alpha, they are difference in equation is that in alpha you have theta, theta, theta. Whereas in case of beta, you will have same equation, but in place of theta, you will put theta plus 90. So beta is equal to minus epsilon x plus epsilon y cos theta plus 90 sine theta plus 90 minus gamma xy sine square theta plus 90. Okay, now using the identities that sine theta plus 90 is cos theta plus 90 is minus theta. So beta will become minus epsilon x plus epsilon y minus sine theta into cos theta. Okay, cos theta plus 90 is minus sine theta, and sine theta plus 90 is cos theta minus epsilon xy, then sine square theta plus 90. This is basically cos theta. So square of this will be cos square theta. So now your beta is minus epsilon x plus epsilon y times sine theta cos theta minus gamma xy cos square theta. Okay, now we say that gamma x dash y dash is equal to alpha minus beta. So now we have to equate equation 5, which is for alpha, equation 6 for beta in this equation, and then after simplification we will get the final answer. So please do this. Gamma x dash y dash is equal to minus epsilon x plus epsilon y times cos theta sine theta minus gamma xy sine square theta minus epsilon x plus epsilon y sine theta cos theta minus gamma xy cos square theta. So when you will simplify, first open up these brackets. Okay, first open up these brackets. So then you will open up these ones. So minus epsilon x plus epsilon y cos theta sine theta minus gamma xy sine square theta. And when you will open up this bracket, this will become positive. Positive minus epsilon x plus epsilon y sine theta cos theta minus this will also become positive plus gamma xy cos square theta. Further simplification, this and this they are added together. So gamma x dash y dash will be equal to 2 times minus epsilon x plus epsilon y cos theta sine theta plus gamma xy cos square theta minus sine square theta. Now using the identities, we have to further simplify. So gamma x dash y dash is this minus epsilon x plus epsilon y. 2 sine theta cos theta is identity sine 2 theta. So you are getting sine 2 theta here. Then this cos square theta minus sine square theta identity is cos 2 theta. So gamma x dash y dash is equal to minus epsilon x plus epsilon y sine 2 theta plus gamma xy over cos 2 theta. And after simplification, you will get your this final equation for the shear strain. Shear strain is gamma x dash y dash. Because now we want to have the expression in the similar term, a similar way as for the shear stress. So that's why we are dividing whole of the equation with 2. Okay? So now gamma x dash y dash over 2 is equal to epsilon x plus epsilon y over 2 sine 2 theta plus gamma xy over 2 cos 2 theta. Is this clear? Now come to the book. In the book, we have derived all these. Guys, can you see this slide?
Yes, sir.
Now you have seen this. We have derived all this for epsilon x dash and gamma x dash y dash. All this we have done. Now only thing left is to calculate this epsilon y dash. So according to the established sign convention which we have done, epsilon x dash is epsilon x dash is positive, the element elongates in the positive x direction. If x dash y is positive, the element deforms as shown. AOB angle will reduce. Now the derivation of epsilon y dash is just this one. If the normal strain in the y direction is required, it can be obtained from equation 10.5. This is equation 10.5. In this equation, you will just simply replace, to get the expression for epsilon y dash, you will just replace theta with theta plus 90. And after simplification, you will get this equation, which is exactly similar to your sigma y dash, only the stresses are replaced with strains. Is this clear? Is this clear?
Yes, sir.
If this is clear, then that's it for today. We have to proceed. We proceeded quite fast today because 15 minutes I have to wait for you guys to come to the class, and I think 10-12 minutes were wasted because you guys did not let that the mic was mute. 11 minutes. Okay. Now tomorrow we will have a class, a 1 hour class. आपका मेरे ख्याल से होता है तीसरा लेक्चर है कि चौथा है?
सर कल सेकंड लेक्चर है 9 to 10.
ठीक हो गया. 9 to 10 का मतलब है कि तुम लोग भी 9 to 10 आ जाना.
ओके सर.
Tomorrow basically we have to do numericals. हाँ, numerical start करने और साथ हमने principal strains वाली derivation भी करनी. Okay guys, thank you very much for your time. Take care, and I will catch up with you tomorrow and then on the Friday as well. Okay, thank you very much for your time. Take care. Allah Hafiz. 1 second, sorry, I forgot to download your attendance.